Good evening, all. I'm Arpita Biswas. Today, we are going to start the week one of microelectronics device to circuit. So, wait for 2-3 minutes. So, if anyone also want to join, you can. Then we will start our session. Am I audible? Hello. Um, you can unmute yourself and confirm it. Am I audible?
Yes, ma'am, you are audible.
Oh, okay. Okay, so wait for 2-3 minutes. Then we will start. So, okay, let's start the session. So this is week microelectronics device to circuit session. This is the problem solving session. I'm Arpita Biswas, a PhD scholar from IIT Jodhpur in electrical engineering department. And this is more details about me. I've done my BTech in electronics and communication engineering and MTech in microelectronics from IIT Jabalpur. And this is my Google Sites. And this session is from 7 to 9 p.m. Okay. So in this session, basically, we are going to discuss about some MCQ question, and if you have any doubt in this class, so you can also mail me personally. So in the next class also, we can discuss about some of this question. Okay. So today is the basic introductory session. We are taking some 30 to 32 MCQ type question. So here we are going to discuss about it. Okay. So let's start the session. And this is today's class is almost the introductory session. So this is the question number one. Which of the following is true for the unipolar devices? First option is the current flows due to the one type of charge carrier, either majority or minority. And second option is the current flow due to the both majority and minority carriers. And option C is the BJT called BJT are called the unipolar devices. And option D is the current does not flow in these devices. So go through the question carefully and they try to give the right answer. And please unmute yourself and then and there's no hurry, you can take your time, but at least try, all of you. So which of the following is true for unipolar devices?
Option B.
Okay, option B. Um, okay,
First option.
okay. Anyone else? There are some more students. Ramya, that's the right answer.
First option, ma'am. Ma'am, hello.
Okay. Option A. Manisha, what is the right answer?
Ma'am, option A.
Okay. Bala Surya. Hmm. Is my slide visible or not?
Ma'am, I am unable to see
No.
this slide, ma'am.
Sorry.
Your screen is not visible.
Just a minute. Maybe I'm suffering from network issue. Can you see the slides?
No, not yet.
Yeah, I'm trying to share. Wait just a minute. What happened? Mm. Please wait for a minute. I'm trying to share. Now can you see?
Yes.
Sorry for the network issue. So, what's the right answer? I think there's some more students. Haripriya, what is the right answer?
First option.
Okay. So, can anyone discuss about it? Why the first option is the right answer? I think one of you says that the option B is the right answer, right? So, can you little bit elaborate it? Any of you can unmute yourself. And why the option A is the right answer, not the B? Today, I want all of you actively participate on this class. So, please try to give the answer. Am I audible? Hello? Hello?
Yes, you are audible.
Okay, so can you please little bit elaborate why option A is the right answer? So, what is the question here? Which of the following is it true for unipolar devices? So, here the point is the unipolar, right? So, the first option it is saying the current flows due to the one of the type of the charge carrier, either majority or the minority. Okay. And second option is the current flows due to the both majority and minority. So, if both majority and minority, then it is called what? Any of you? If both
Bipolar.
is particular, yes, it is called the bipolar. So for unipolar devices, only one. Okay. So either the majority or either the minority, right? So right option is option A. And what about the option C and D? Any of you? So BJT are called unipolar or bipolar?
Bipolar.
Yes. And the last option, current does not flow in these devices, so it is also not right. So the right option is option A. Okay. So next, move toward the question number 2. So here the question is, in a NPN BJT symbol, the arrowhead on the emitter is always marked dash, whereas in a PNP BJT symbol, the arrowhead on the emitter is marked dash. So first option is the inward and inward. The second option is the inward outward, and the option C is outward or inward, and option D is outward and outward. So go through the question carefully. You can see draw the circuit like how the NP and BJT symbol is look like, and then tell
Option
me what
C,
is the
outward and inward.
yes. Any of you? What is the right answer?
Option 3, ma'am.
Okay,
Third option.
okay. Ankit, what is the right answer?
Third option, ma'am.
Okay. So option C is the right option because in NPN also you can see how it's look like. Like just a minute. How it's look like in BJT, like this type of this then this type of structure, right? This type of structure, right? It's called NPN. So it is outward, right? So in the PNP, it is opposite, so it is inward, right? So option C is the right option. So next move toward the question number 3. Which of the following is it true for the emitter, base and collector region of a BJT? So first option is the symmetric doping and symmetric dimension. Option B is the symmetric doping and asymmetric dimensions. Option C is the asymmetric doping and symmetric dimension. And option D is the asymmetric doping and asymmetric dimension. So carefully go through the option and tell me which one is the right option.
Ma'am, your screen is freezed. I'm not able to see the question.
You are not able to see the question. So this is the question number 3. I think you can see now. Any of you can confirm? Is the screen is visible? Yes, it is visible. You can check your connection. This is the question number 3. Which of the following is true for the emitter, base, and collector region of a BJT? Hmm. Now you can see or you can rejoin.
Yes, ma'am, it's visible now.
Okay, then tell me what is the right option.
Third option, ma'am.
So your answer is the option A.
Ma'am,
Okay,
fourth
anyone,
option.
Rishika, what is the right option? Okay, okay. And I think there is Jane. What is the right option? I want all of you actively participate on this session.
Third,
Hema, okay.
third
Ramya
option,
option.
ma'am.
Sorry, which one?
Option 4, ma'am.
Okay. So I don't know what happened. I think it's been gone. So can anyone explain about this? Why the option B is the right option? I don't know. I think again the screen is visible or it is gone.
Your screen is not visible, ma'am.
Yes, actually, I'm sorry for it. Actually, I'm facing some network issue. That's why. Sorry for it. Just a minute. Uh, Please wait for a minute.
No, ma'am.
Now you can see the slide.
Yes, it's visible now.
Okay, okay. So, what is the right option? Can anyone explain little bit which one is the right option? Hello.
Ma'am, asymmetric doping and asymmetric dimension is the right option, ma'am.
Yes.
Since all the three
Yes.
regions are not equal and the comparatively the emitter is highly doped and hence the dimension and doping is different for three regions. This is the reason.
Yes. So right option is the option D, asymmetric doping and asymmetric dimension. You can, if you see the BGT, yes, the BGT like base emitter and region and collector region, you can see the difference. And later we are going to discuss about why this is different, like why asymmetric doping is required, why the dimension is different. Okay, so later, some two, three, after the two, three question, we are going to discuss about it. So right option is option B. So this is the question number 4. Identify the mode of operation of the NPN transistor connected as shown below. So see the structure carefully. So first option is the cutoff region, second is the saturation, option C is the forward active, and option D is the forward reverse active. So please go through the question carefully, see the structure, and try to find out the right option.
Option A cutoff.
Yes, any of you? Ramya?
Forward active.
Okay. Hari?
Option
What is
3.
Rishika? What is the right option?
Option 3, forward active.
Okay. Any of you like Prashant? What is the right option?
Ma'am, cutoff is the right option, ma'am.
Okay. Rajiv, what is the right answer? Manoj?
I think cutoff, ma'am.
Ma'am, since the VBE voltage is less than VCE,
Hmm.
the cutoff it is in the cutoff region, ma'am. We could calculate by using VBE is equal to VB minus VE, ma'am. They have given voltages for three different junctions. And
Yes.
for VCE, we could calculate by using the formula VC minus VE.
Yes.
Comparatively, the VCE is larger than VBE, and hence it is in cutoff region.
Yes. It is in cutoff region. Good. So the simple way how to find out it is cutoff region or not. So simply see what is the tell me what is the value of this VB. It is less than 0.7 or not. So please
Yes,
calculate.
yes, ma'am. It is less than 0.7.
Yes, it is less than 0.7, right? This is 3 and this is 2.6. So what is the value of it? VBE, it is 0.4, right? So 0.4, it is less than 0.7. So this NPN transistor is in the cutoff region. Okay. So the right option is option A. Good. So next move towards the question number 5. In which mode the BJT need to be operated to act as an amplifier? First option is the cutoff, then saturation, then option C is the active mode, and option D is the BJT cannot use as an amplifier.
Active mode.
Okay, any of you? What is the right
Active mode,
option?
ma'am.
Okay,
Active
Rishika?
mode, ma'am.
Active mode.
Okay, so the right option is the active mode. Good. So can anyone little bit explain why the active mode is the right option? Why not the saturation or the cutoff?
Ma'am, in active mode, the base emitter junction is forward biased,
Mhm,
and the collector and the emitter is reverse biased. But in
mhm,
saturation, both the junctions are forward biased.
mhm.
While the collector emitter junction is reverse biased, it pulls more electrons towards the junction, and hence more current flows through the BJT, and hence it is used as an amplifier in active region.
Yes, so ideally it's a linear reproduction of the input signal. Okay, so that's why this the BJT needs to be operated as an amplifier in the active mode. Good. So next, the question number 6. When silicon when silicon is doped with the dash, an N type of semiconductor is formed. So the first option is the phosphorus, second is the boron, third is the aluminum, and fourth option is the copper. So what is the right option here?
Option B, boron.
Any of you? What is the right option?
Boron, ma'am.
It is N type semiconductor.
Phosphorus, ma'am.
Phosphorus.
Any of you?
Phosphorus.
Rishika? It is boron or the phosphorus.
Ma'am, I think phosphorus.
Yes, Rajiv. What is the right answer?
Phosphorus.
Yes. Why phosphorus?
Ma'am, it is a
Because it increases
pentavalent liquid.
pentavalent property.
Any of you, one of these. What is the reason? Why phosphorus is the right option? When silicon is doped with phosphorus, an N type of semiconductor is formed. Okay, so what is the reason behind it? When the silicon is behave like N type, when it is behave like P type. Can anyone little bit explain this?
Phosphorus
Phosphorus
has
is
five.
so it provides an extra free electron.
Okay, so it's provide the extra free electrons. Okay, Rishika, you are also telling something?
Phosphorus has 5 electron in its outermost shell.
Yes, yes. So the right option is phosphorus, right? So next move toward the question number 7. So beta for an NPN transistor is 40. Alpha for the same transistor would be dash. First option is 0.995. Second option is
In question
0.997.
number 7, it's not visible, ma'am.
It is not visible. Any of you can confirm is this slide is
Not
visible or
visible,
not?
ma'am.
Screen freeze.
Visible,
Just
ma'am.
question number 6 is not visible. Just a minute, I'm just sharing it again. I'm sorry for the disturbance. Just give me a minute. Now can you see the slide?
Yes, ma'am.
Yes.
Okay, so actually I'm putting my video off. I think I'm facing some network issue, that's why. So can you solve this question? Beta for an NPN transistor is 40. Alpha for the same transistor would be, first option is 0.995, second 0.997, third option is 0.983, and option D is 0.975. At first, tell me what is the relation between this beta and alpha and what is
Alpha
it?
is equal to beta divided by 1 plus beta.
Okay.
And
So
the
what is the
answer
value?
is last option, ma'am.
Any of you?
0.975.
Okay. Hema, what is the right option?
Fourth option, ma'am.
Okay, so the right option is the fourth option. So next move toward the question number 8. Can you see the question number 8? So it is the calculate the emitter current IE and the collector current IC in a transistor for which the beta is 120 and IB is 2 microampere. The first option is IC is 60 microampere, IE is 62 microampere. IC second option is IC is 240 and I is 240. And option C is IC is 240 and I is 242. And option D is IC is 60 and IE is 58. So what is the right option?
Option C, ma'am.
Okay. Anyone else? Jen, what is the right option?
C, ma'am. Option C.
Okay. Ramya, what is the right option? Manisha? Manoj, what is the right option?
C option, ma'am.
Okay. Can anyone little bit explain how it is option C? How to calculate it?
IC is equals to beta IB.
Okay. So from here you have calculated, right? So what is the value of IC? So what you have done? Just a minute. I'm showing it. So at first see what is given here, like beta and IB, right? So what we know, IE is equal to, what is the value of IE? Tell me, what is the equation?
IC plus IB.
Yes, IC plus IB. Just ignore my handwriting. So here, as we can see that IB is given, right? IE equal to 2 plus IB.
We have to calculate IC. IB is given.
Yes, IB is given, so it is IC, right? IC. So next, what is the value of beta? Tell me.
IC by
The
IB.
IC by IB.
Data value given in question mark.
Yes. So from here we can calculate what is the value of IC beta into IB, right? So beta into IB equal to 240. And then tell me what is the value of IE? It's 2 plus IC, right? So it is 242. So what is the right option? Right option is option C. Am I audible?
Yes.
Okay. So all of you got the answer. This is the option C. Okay. So next, the question number 9. The dash region of a BJT is heavily doped. So first option is emitter, then base, collector, or drain. So which of the
Emitter.
Emitter,
yes emitter? Ankit, what is the right option?
Emitter, ma'am. Emitter.
Emitter.
Okay. Okay. So the right option is emitter. Later we are going to discuss why this region is heavily doped. So this is the question number 10. In the circuit shown below, the NPN transistor is biased in dash configuration. So carefully see the structure and then tell me it is in common emitter, common collector, or common base, or common gate. which which mode
Common
is it?
emitter.
Okay.
Common.
Anyone else?
Common emitter, ma'am.
Common emitter.
Haripriya?
Common emitter, ma'am.
Balasurya? Okay. So anyone little bit,
Madam, it is in
just
common
little bit
emitter
explain
mode.
about why it is common emitter.
As
Emitter
the
is
emitter
grounded, so it
terminal is
is
grounded,
common.
it is
Yes.
common
So
emitter, ma'am.
this emitter is grounded. That's why it is the common emitter. So this is the question number 11. Why is the emitter doped more heavily than the collector? First option is to reduce the power loss. Second, to maximize the recombination. Option C is to increase the injection efficiency. And option D is to isolate the base current. So what is the right option? Take your time and try to solve. And I hope all of you actively participate.
Option C, ma'am.
Okay. Any of you? Molly, what's the right option? Why the emitter doped more heavily than the collector?
Ma'am, is it C?
Okay. Then Haripriya,
Yes, ma'am. Option C.
Rishika,
Ma'am, I think it's option B.
maximize the recombination. Uh,
Yes, ma'am.
Ankit, what is the right option?
Option C, ma'am.
Okay, Ramya. Yes, right. Manoj,
Either option A or B, ma'am, but not sure.
okay. So, Shivraj, what is the right option?
Ma'am, C, ma'am.
Can you little bit explain about it? Option one by one, you can discuss about it. To reduce the power loss, is this option right or not? That's why the emitter dopes more heavily than the collector. Is this the right option? What do you think?
No, ma'am. Option A is wrong option.
Yes, option A is the wrong option. And then coming to the option B, to maximize the recombination, is this the right option?
No, ma'am. That too is not our desire in BJT. That's the wrong option.
Okay. And what about the option C, to increase the injection efficiency?
That is the correct option, ma'am.
Yes, the correct option is to increase the injection efficiency. Okay. And option D is also not the right one, to isolate the base current. No. The option C is the right option, to increase the injection efficiency. Okay. So next question
Huh?
is question number
Huh?
12. Which terminal of a VGT is always connected to the arrow in the symbol? First option is the collector
Emitter.
base emitter, and option D is none of the above.
Emitter option C.
Okay,
Emitter, ma'am.
okay. Shivraj, and this is basic question, I think. Just this is the introductory session. Know about all of you know about this basic things. This where the arrow is given. This the which region is an common emitter or not. Where the arrow is, yes, the base, or which one is the heavily doped. Which one is the like smaller region or smaller area. Why? This type of question we are this in this section we are going to discuss about almost the introductory session. Okay. So what is the right option, Manoj?
Emitter, ma'am.
Shivraj? Yes, emitter. As already I think I have drawn it. This is the BJT. Like this region, what is the name of this region? Like this upper one? Tell me.
Collector.
Yes, this is called collector, okay? And this region is the base region, and this is the emitter. So arrow is always given to this emitter region, okay? So the right option is option C, okay? So next is the question number 13. Which of the following is true for NPN transistor in active mode? First option, base emitter junction is reverse bias. Then second option, base collector junction is forward bias. Then option C is the both junction and forward bias, and option D is the base emitter forward bias and base collector is reverse bias. I think in previous question also we already discussed about this question. Which one? One of you I think told that which one is this forward bias and which one is the reverse bias in the active mode. So tell me what is the right option?
Last option.
Yes. Any of you?
Last option, ma'am.
Okay. Manisha, what is the right option?
Last D.
Okay. Prashant, what is the right option? Which of the following is true for the NPN transistor in active mode? Ankit, what is the right option?
Option D, ma'am.
Option D. Yes. So the right option is option D. Good. Base emitter is forward bias and the base collected is in the reverse bias. And in the next class, we are going to like more details. In details, we are going to discuss about this circuit diagram, the forward bias and this reverse bias, and we can going to solve some of the numericals also. Okay. So this is the question number 14. If the emitter current IE is 10 milliamps and the base current is IV is 0.2 milliamps, calculate the collector current. And I think this is also basic. So calculate it. How to calculate this IC? Tell me. There's the equation. There's a small equation of the relation between this IE and IBIC. Tell me what is the right option.
IC equals Psi minus IB.
Okay, so calculate it.
9.8 milliampere.
Is this the right option?
Yes, ma'am.
9.8, ma'am.
Yes,
Which
9.0.
yes,
So let's solve the question. IE equal to what is given here? It is, sorry, IE we have to calculate, right? Sorry, IE is given 10. So what we know, IE equal to IC plus IB, right? IC plus IB. This is the equation. So we know about this IE, it is 10 milliamps, and IC we have to calculate. And then we are going, we have this IB 0.2. So what is the value of this IC? It is 9.8. Okay, 9.8. 9.8 milliamps. So next question. What is the significance of the doping concentration in emitter, base, and collector? Tell me what is the significance. In the first question, I think we have discussed first or second question, right? It is asymmetric in the doping and also asymmetric in the area or the structure. Okay. So now tell me what is the significance of the doping concentration? Where the it is heavily doped, where it is lightly doped, and why? Like, can anyone of you little bit explain about it? Hari, Ankit, which reason is
The
heavily
emitter
doped?
is heavily doped
Okay, and what is the reason behind it? I think we have discussed in the previous question. Emitter is
to
heavily
increase
doped. Why?
the injection
Injection
efficiency.
efficiency. Yes, good. And what about the base? It is moderate or
It
the
is
lightly doped?
it's lightly doped
Yes, base region is lightly doped. So what is the reason behind it?
to allow the carriers from emitter to collector.
Okay, and another reason, it
To
is like
reduce
mainly,
recombination.
yes, it is the main reason is to reduce the recombination. Okay, and what about the collector?
It
Moderately
is
doped.
moderately doped.
Yes, it is moderately doped. And now tell me what is the reason behind it? Like why it is moderately doped? What? What is the reason? Tell me. To
It
power
generates
handling.
maximum power heat
Yes.
in the form of
So
heat.
collector is moderately doped for power handling. Okay. So next question. What is the base? Why is base current small? Any of you? In the numericals also, you have seen like the emitter current is 10 milliamps and the base current is 0.2 milliamps, and we have to calculate the IC, right? And it is near about this 9.8. So why this base current is so small?
Since it is lightly doped, recombination is very less, so hence the current is also.
Yes, because the base is lightly doped and thin, few electrons recombine with the hole in the base. Okay, thus only a small base current is needed to sustain the recombination. Okay. So next move toward the question number 17. In NPN transistor active mode, most electrons. First option is recombine in base. Second option go back to the emitter. Third option are collected by the collector, and option D get trapped in the depletion region. So go through the question carefully and then tell me what is the right option. In NPN transistor active mode, most electron. What?
Are collected.
Are collected by collector.
Okay, Manoj, what is the right option?
C option, ma'am, are collected by collector.
Rishika?
Ma'am, C option are collected by collector.
Yes, the right option is option C. Good. So this is the question number 18. Which mode of
Ma'am, in the
BJT?
previous question, ma'am,
Yes. Hmm.
in the previous question, you have asked what is the reason for the base current to be very small, right? Does
Sorry.
anybody answer the reason why?
So, uh,
Ma'am, let me tell my
yes, what
perspective.
is C?
Ma'am,
Why
in most of
is
the
base
NPN
current?
transistor, yes, ma'am, let me explain.
Yes. Okay, okay.
In
Tell
most
me.
of the NPN transistor, the
Mhm.
recombination will be very much low. That's what we desired.
Okay.
The recombination should be very much low. So to compensate the recombination of the electron and holes, the base current will be flowing from the base junction towards the base junction. So since the recombination is low, ma'am, only the small pair of electrons and holes will be lost in the base. So to compensate that, only small number of current will be flowing through the base. This is the reason why base current is very low. Am I correct, ma'am?
Yes. Yes, because the base region is lightly doped and thin, few electrons recombine with hole in the base region, and thus only a small base current is needed to sustain the recombination. Yes, you are right. So next we are discussing about the question number 18. Which mode of the BJT operations has both junction forward bias? So it is active region, saturation, cutoff, or reverse active.
Saturation.
Yes, the right option is saturation. So in active mode, already we have discussed the collector and the base. It is in the forward, reverse, and the emitter and the base is forward. And in the saturation region, this both region is in the forward bias, right? So the right option is option B. So next, the question number 19. The reverse active mode is rarely used because first option is collector is heavily doped. Second, base becomes emitter. Option C, gain is very low. And option D is depletion bits becomes zero. So what is the right option here? The
Gain is
reverse
very
active
low.
mode. Okay. Jane, what is the right option? Manisha, what is the right option? And I think in the next class also we can more details and we can draw the structure. Which one is the active region? Which one is the reverse active? Okay. So normally in this section we are going to discuss about just little bit. So in the next question we can solve the numericals also. Okay, and then I will put the structure like the circuit diagram, so it will more clear to you. So now tell me the reverse active mode is rarely used because collector is heavily doped, base region base becomes emitter, or gain is very low, or depletion bits become zero. Balasuriya, what is the right option?
Ma'am, I think base becomes emitter.
Manisha,
I think gain is very low.
Molly,
Ma'am, C option.
uh, can you little bit explain, little bit just? See,
So means option
when
C
we
is
are
the correct
like,
answer.
yes, option C is the correct answer because already we know now what we want. Gain means the output. Normally, what is the gain? Like the output by input ratio. So if the gain is very low, so what is the use, right? That's why the in the reverse active mode is rarely used because the gain is very low. Next class we are going to discuss about it in more details. Like we can draw the circuit diagram also. Okay. So this is the question 20. I think already we have discussed. How are this alpha and beta related? What is the equation between it?
Alpha equal to beta by 1 plus beta. Ma'am.
Okay, and the another equation, like what is the value of beta?
Beta equal to alpha by 1 minus alpha.
Yes, good. Alpha is equal to beta by 1 plus beta. And beta equal to alpha by 1 minus alpha. Rima, you can please mute yourself. So this is the question number 21. If beta is 100, then what is the approximate value of the alpha? Please calculate it. First option 0.90, second is the 0.95, and option C is 0.99, and option D is 1. So if beta is 100, what is the approximate value of the alpha?
Option C 0.99.
Option C.
Yes, option C is the right option. Good. So next is the question number 22. So given beta is 100 and IB is 20 microampere, find the IC and IE. You already know about this equation like IE equal to IC plus IB. And here beta is given and IB is given. Now tell me what is the value of IC and IE. Emma, please mute yourself. The noise is coming. Yes. So please tell me what is the value of this IC and IE.
IC is 12,000 and I is
Tell me how to calculate the value of IC. How you have
IC equal
calculated?
to beta times IB, ma'am.
Yes. So beta times IB. So what is the value of beta? Beta is 100 and IB is 20. So what is the value of it? IC equal to what? Like 2 milliamps, right?
2 milliamps. Nice.
Yes.
Yes,
So what is the value of IE? Now tell me.
ma'am, we can use the
IE
relation
is
of
equal to IC plus. Yes, I equal to IB plus IC. So here the IB is given, like IB is 20 microamps, and IC we have already calculated 2 milliamps. So what is the value of it? 2.02 milliamps, right?
yes,
Let's
ma'am.
see. So here I see how to calculate it. Those who are not done the calculation, you can see here, this is the beta, okay? Just ignore the handwriting. Beta into IB. This is beta into IB. So what is the value of it? 100 into 20 microamps. 20. This is microamp. So what is the value
Ma'am,
of
your
it?
speech got freeze. Um,
Okay, it is, you can, just a minute, I'm sharing it again. Just a minute, I'm trying to share it again. Yeah, again, I'm facing some network issue. Just give me a minute. Just wait for a minute. Because of the network issue, I'm not able to share. Yeah, screen is not visible. Just a minute. Actually, I'm facing some network issue. I'm trying to share. Just a minute. Just. Can you see the slide? I'm sorry for it. Actually, now I can arrange this. Can anyone please confirm? Can you see the?
Yes, ma'am, it is visible.
Yes, ma'am.
Okay, okay.
Ma'am,
Thank
it's visible.
Okay, I'm sorry. Sorry for the disturbance. I think we are in the question number 22. Mhm. 20, 22. So in question number 22, what is the right answer? I can explain here. So the question number 22, the right answer is the IC value is 2 milliamps and the IE value is 2.02 milliamps, right? So next we are moving towards the question number 23. So if the VBE is 0.7 volt and VT is 26 millivolt and IS is 10 to the power minus 15 ampere. Now calculate the IC. Tell me what is the value of this IC? What is the equation of this IC and the IS? Any of you? Hello? Anyone can tell what is the equation between this IC and the
I
IS?
think IC is equal to IS into exponential of VBE by VT.
Yes, right. So everyone note this equation like IC equal to IS into e to the power VBE by VT. And now calculate. Here all of the values are given. Like VBE is 0.7, VT is 26 millivolt, IS is also given. Now calculate the value of IC. And the equation is IC equal to IS into e to the power VBE by VT. So at first tell me what is the value now put in the equation like IC equal to IS. So what is the value of IS? Is 10 to the power minus 15. Okay. Into e to the power. What is the value of VBE? Is 0.7 by what is the value of VT? 0.026. Okay. What is the value of VT? 0.026. And now calculate it. Right. 10 to the power minus 15 into e to the power. What is the value of this 0.7 by 0.026? It is e to the power 26.92. So what is the final value of it? Like 10 to the power minus 15 into 5.4 into 10 to the power 11. Okay. So the final value is 0.54 milliamps. Everyone got this answer? Just put the in the equation like IC equal to IS into e to the power VBE by VT. Actually, here I can write I directly open in the mail. Everyone got the same answer, like IC equal to 0.54 milliamps. Please calculate it. IC equal to IS into e to the power VBE by VT. What is the value of IS? 10 to the power minus 15. Okay. And then what is the value of the VBE? Is it like e to the power 0.7 by VT. VT is 0.026. So the final value is 0.54 milliamps. So can we move towards the next question?
Yes, ma'am.
Okay. So here the question number for 24. If the beta is 100 and IB is 50 microampere, now calculate the IC and IE. I think similar type of question already we have solved. So all of you can do solve this question. Beta given, IB given. So what is the value of IC and IE?
Hello,
Yes.
ma'am. Can you share the recording also, ma'am?
Yes, the recording I will share in the list also, and also I will put this today's class na, in my YouTube also. So from there also you can see.
Okay,
Okay,
ma'am. Okay, ma'am. Thank you.
okay. This PPT and this recorded video I will share.
Hello, ma'am. Hello.
Yes,
In your YouTube channel, ma'am.
yes.
Okay, ma'am.
I think in the NPTEL also, NPTEL also, from the NPTEL side, you got the link, na, where no, the TAs will share the related the link.
Yes, ma'am. Yes.
Yeah, okay. So in that list, I will share the recorded video and which I have uploaded in the YouTube and also the PPT. So what is the answer? Like what is the value of this IC? Like how to calculate the IC? Tell me.
Beta into IB, ma'am.
It is yes, it is beta into IB. So the value of beta is 100 and the IB is 50. So what is the value of IC? It is 5 milliamps,
5,
right?
5 milliamp.
Yes. So what is the value of IE? Tell me.
5.05.
5.05.
Yes, 5.05 milliamps. So next move to the question number 25. What is the main reason for the early effect? First option is the change in doping. Second, the increase in emitter area. C is the base width modulation, and option D is the increase in BV. In the next class, I will details about the detail. I will discuss about in details the what is the early effect and the diagram. Okay. So now just know little bit about what is the main reason. In the next class and further class, we will discuss about it. We
I mean,
put the
base with
diagram.
modulation, option C.
Yes, base width modulation. The right option is option C. So, in this is the question number 26. What is the operating principle of a BJT in forward active mode? Anyone, any of you? Question number 26.
B.
What is the operating principle of a BJT in forward active mode?
The base emitter should be forward biased and the base collector should be reverse biased, ma'am.
Yes, the base emitter junction is in forward bias and the collector base junction is in the reverse bias. Good. So next question 27. What is the significance of the Q point in a BJT amplifier?
And Q point is an operating point where
Hmm.
the BJT works at its highest maximum performance. That is, it could
Okay.
amplify the most of the signal to its maximum.
Okay. Any of you?
After Q point, the BJT breaks down.
Okay. Molly, what is the right answer? Jan,
Ma'am, yeah,
yes.
yes, ma'am. Ma'am, here, ma'am, it establishes a relation over here. Like, uh, but ma'am, I'm not very certain about the.
Okay, it's okay. Just tell me. Just if you have a little bit idea about it, then you can tell me. There's no that I'm not expecting all of you know all the details, but at least try. Um, Ankit,
Then Q point determines the operating point at which we will operate the transistor when we do not apply any input signal from outside.
okay, Prashant,
That's what I said. That Q point is an operating point where the
hmm,
BJT has its maximum performance, and it is desired point. Uh,
hmm,
it is actually a point in a DC load line graph. It could be marked by finding the value of ICQ and VCEQ.
hmm. Okay. So the Q point is the DC bias point around which the transistor amplifies the AC signals linearly. Okay, and placing it in the active region ensures the low distortion and consistent gain. Okay, so moving toward the question number 28. So here also is a little bit small numericals like IB is given, beta is given, and again calculate the IC and IU. So what is the value of it?
2 milliamps and 2.02 milliamps.
Yes, good. So next, the question number 29. In common emitter configuration, which junction is forward biased? Like the base collector, base emitter, or none?
Base emitter C.
Okay, any of you? Which junction is forward biased?
Base emitter on C.
Okay, so the right option is option C, base emitter. So next, the question number 30. If VBB is 0, what is the operating region of a BJT? Active, cutoff, saturation, or reverse active?
Cutoff region, ma'am.
Okay, any of you?
Because it is followed by a
Already, I think we have discussed what is the like formula for the cutoff region. It is if it is less than 0.7, right? In the first, I think first is second question we have discussed. If it is less than the 0.7, then it is right in the cutoff region. So if VBV is 0, then it is in the cutoff region. Option B is the right option. Then the question number 31, which configuration provides the base voltage amplification? First option is the common collector. Second is the common emitter. Sorry, first common base, then common collector, then common emitter, or all equally. So which configuration provides the base voltage amplifications?
Common emitter.
Yes, common emitter. Any of you? So right option is the common emitter, option C. So in the question number 32, in the CE common emitter configuration, why the RB chosen to be large? First option, reduce the base power. Second, limit the base current to micro range. Option C, avoid the thermal runaway. And option D, the increase the VBE. So in the common emitter configuration, why RB chosen to be large?
Ma'am, it
Option B.
avoids thermal runaway.
Yes.
Option C,
Option
ma'am.
Option B, ma'am.
Can you
Option
little bit
B.
Yes, can you little bit explain about why not C, why option B? This you always want the like a small base current, right? Because of the recombination already we have discussed. So limit the base current in the microampere range. all of the numericals, if you carefully see, you can see the base current is in the microampere range, and all the IE and the IC is in the milliampere, right? So the limit the base current to microampere range. So option B is the right option. So this is the last question. The question number 33. Which of these is true about the common base configuration? First option is the has high input resistance. Second is offer the current gain beta. And option C is the IC equal to alpha into IE, where alpha almost equal to 1 is, and option D is commonly used for the power amplification. So what is the right option?
Option C, IC equal to alpha into IC.
Yes, the right option is option C. So today we are ending our session here. Next we are going to discuss more about the in the next session next Tuesday 7 to 9 p.m. So you can also not directly mail me if you have any doubt about it. Okay. You can directly mail me. So in the next class or maybe after next to next class we can discuss about it. Okay.
Madam,
Ma'am, I have a
excuse
doubt.
me, madam. One doubt.
Yes.
Madam, actually, you this will be shared. This video recording will be shared.
Yes, this video recording and the PPT I will share.
Okay, madam.
And
Madam,
I think
last.
and I think in the from the NPTEL side you can receive a mail where all this link is given. Okay. Or if you don't receive, I will share in the next class the link. Okay.
Okay, madam. One more thing. In the previous, in the last session, last session one also we haven't received, madam. For that purpose, we have asked.
Uh, Sorry, in the last session, actually this is my first session. There is two TA. Okay. And the
Okay.
from Harvard, his side, they are teaching. And also again, I'm also teaching from the same subject. Okay. So
Okay.
whatever here I'm going to like solve about some of the MCQ or some numericals. This is in like my way, and he is totally different, but from the same class. So in his or her class, if you have any doubt, you can directly ask him or her. Or if you have any doubt in my class, you can directly ask him. Okay.
Okay. Okay. So they will explain the concepts, and you will be solving the
Yeah,
MC.
here actually I'm here for solving all this. Like it will little bit helpful for you. Okay,
Yeah.
he already sir taught you the theoretical concept, all these things, and
Yeah.
the first year is also teaching like that. And here I am going to discuss about like 30 to 40 question we are going to solve here. So, or
Yeah.
any if you have any doubt further, so here you can solve it. Okay,
Okay, madam.
okay.
Okay.
So all of you
Madam,
Ma'am,
can.
can I get your videos in the NPTEL in the Google search for this course
In the
previous?
YouTube, in the you actually there is a rule that all the PA have to upload their recorded video in their YouTube, and then we have to upload share the link in the they have share a page. So in there I have to upload share the link. So from there you can get.
Yeah, madam. Why? Because why I'm asking this question is I have registered for other course digital circuits. The same thing is happening. That's why uh, I'm asking. Suppose if you have given any previous NPTEL lectures on this course, also we can able
Yes,
to
yes,
watch.
I have already given there. Like I have already in the last year also I have taught this subject also the microelectronics device to circuit I already taught, and also the fabrication is and sensor and actuator. In the fabrication I have taken I think 3 to 4 courses. So I have already uploaded in my channel also.
And
So
ma'am, what's the
Because
name of the channel?
yes, madam. Can you share your
uh,
channel? I have searched the channel. I am not able to get that microelectronics. I have got semiconductors.
no, just a minute. Just a minute.
Yes,
Okay.
ma'am. May you please
Yeah.
share the URL as well for that?
Just a minute. Just a minute.
Yes.
At the rate, I think at the rate Arpita Biswas 9826. Can you search on the YouTube? I think you can got my
1 minute, madam. I'm searching.
because last class I have taken the micro sensor implantable devices. But if you see carefully, you can see I have already taught this class.
Yes, ma'am. At the rate.
At the rate Arpita Biswas, 9826. And also the PPT, whatever I taught in the class, I will share it. And this is my mail ID, that biswas.5 at the rate iitj.ac.in. So from this mail also, if you have any doubt, you can directly share the problem or the question. So further class, I can discuss it. Because for here we are almost going to discover 30 to 40, yeah, 40, 35 questions.
Madam,
So
1
if it
minute.
is not,
Arpita Biswas gap is there, madam.
no, there is no gap. At the rate Arpita Biswas 9826.
Ma'am, may I
Just
share the URL here? I have got the channel. So
here I have shared my videos like previous classes. Yeah, first
yes,
class you can see the week 13 microsensor implantable devices. In the last class I have taken before 3 months.
yes, ma'am.
Ma'am, I have a doubt.
Yes.
Ma'am, you told about early effect. Can you bit explain what is that?
Just a minute. Can any of you now tell me? Any of you can little bit explain about the early effect? Do you
Ma'am,
know
I could
about it?
explain about the early effect, ma'am.
Yes, tell me. Because
So
this
early,
section, yes, tell me.
so early effect is one of a non-ideal effect in a BJT, ma'am.
Hmm.
So normally in a NPN transistor, the BC junction is reverse biased. It is
Hmm.
reverse biased up to a particular extent. So when we keep
Okay.
on increasing the reverse bias voltage of the BC junction, the depletion
Yes.
region across the BC junction increases, and the
Yes.
depletion
Across the.
region further keeps on increasing, and
Hmm.
after a certain point, it reaches the base depletion region, base emitter depletion
Hmm.
region completely. That is, it occupies
This is
the base
called.
junction completely, and there will be
Yes.
no base junction existing in the transistor.
Hmm.
So because
Only.
of this effect, more collector current passes through the transistor, and it will
Hmm.
become, how could I say, it is a thermal runaway. More power dissipation will be lost, and
Hmm.
the transistor becomes burnt.
Yes. So this is called the early food. In the next class, we are going to actually. I think you have doubt about it because I have not put it the structure. So in the from the next class, I will put the structure. Okay. In the early effect, why it is happening and thus how it is look like. Okay. So
Okay,
have you
ma'am.
got? So have you got the channel?
Yes, madam.
Yes,
Yes,
ma'am.
madam.
Okay.
Yeah,
Okay.
week 1 microsensors is there.
Yeah, I have taken, I think, the microsensor implantable devices, then sensor and actuators, and also the like this microelectronics device to circuit. You can go through it and you can search whatever is.
Yeah, mostly
Yeah,
we are able to
I
see
think
micros.
1 year, yes, from 1 year, before 1 year I have taken, like you here you can see the microelectronics device to circuit. The I
Only
think I have
week 8
taken.
we are able to observe,
No, no,
madam.
no. Here you can see the week 12, then week 11. Yes, I have taken the 12th class from this microelectronics device to circuit.
Okay, okay. We will see, madam.
Okay, sir. Okay, so we are ending our session here. Next we will meet you next Tuesday, 7 to 9 p.m. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you. Very wonderful session.
Ma'am,
Yes.
when is the another session, ma'am? When will we come to know another session will be there?
Sorry, actually there is some noise. I can't hear you. Can you please repeat? Hello.
Hello? Hello, ma'am. Excuse me, ma'am. Hello, ma'am. Ma'am, I'm audible.
Yes, tell me, what is
Ma'am,
the issue?
when will we come to know under the session with details?
Sorry, I'm not able to hear you. Hello.
Ma'am, can I take it?
Are you asking about the link or anything?
I'm asking about the when will we having another section, ma'am? Another session.